right now, about 400 kilometers above our head, whizzing around the Earth at over 28,000 kilometers an hour, is a satellite. And sure, there's lots of satellites up there, but I care about one in particular. One that a team of engineers and students spent years working on. And I, in particular, spent 3 years working on the flight software that runs that thing's brain. And I got to see it in person once, and I even got to go down to the launch in California and watch it go up to space.
Real separation confirmed.
But I want to see it again. So how do we look at a satellite once it's already up there? Well, the short answer is you don't. You can't see it. It's too far away. It's too small. Whole thing's only about this big. So what else can we do? Well, we could talk to it, but that's expensive and a little bit illegal. So the next best thing we're going to do is we're going to point at it. We're going to take a little pointer and we're just going to figure out where the satellite is in space and point at it. Thing is, that's tough. You can't just simply point up and hope we're near the satellite. I mean, we'll be right eventually for a millisecond, but then that'll be out of date and that won't work. So what we need to do is we need to have a system that can move the pointer and tell us where it is. And it should even have the ability to point through the Earth when it's on the other side of the Earth. Phase 1, we need the data. And how do we get the data? Well, we need to use this really old format from the 1980s called TLEs. And they're this simple format called the 2-line element. This one actually has 3, but that's fine. And it has a bunch of data how to calculate the satellite. And where do we get this from? Well, we get it from a website called Celestrak. And Celestrak will send this over to our code. And this code isn't good enough. It doesn't tell us where the satellite is yet. It gives us instructions for how to propagate the orbit. And so we send it to Joshua Ferreira's implementation of SGP4, an orbital simulation. And then this spits out what are called look angles, and this tells us where we can actually look for the satellite. And this also needs to take into account where we are on Earth and where North is. Alright, so then we move on to phase 2. So we have these look angles, we take these look angles and we send them to the Raspberry Pi. They're already on the Raspberry Pi. And then this spits out data from the Raspberry Pi to our stepper motors. And this tells it to go, tells the azimuth and elevation which way to point. Azimuth is which direction, north, south, east, west, and elevation is how high up or down to point. Alright, so with that, we should be good to go. Alright, here's the plan. We've got a box that can rotate in a few directions. So see, this arrow can move up and down, and then this can rotate side to side. And if we look inside, we'll see we have another stepper motor here that's driving this pulley and rotating the whole box. And then we have a slip ring here, which should allow us to rotate around and around as many times as we want. So I think we ought to send this off to get cut and see what happens. We went through all that work and we got it all built and it works perfectly, right? No. There were multiple failed attempts, things forgotten in the CAD that I had to go back and add, artwork that we wanted to change that wasn't really the vibe, and this kind of looks like a satellite, also kind of looks like a toaster, maybe not a toaster, it just doesn't look very good. So we changed it all, and we even went around and designed a brand new PCB, and we can link this if you guys are interested. It's not a very good one, but it's here, and it gets the job done. And then we have it all hooked up, and this is what we got. Looks pretty close to what's in the CAD. Okay, moment of truth. Let's see if this thing runs. Ready, set, go. Well, that's not going to work. Let's try taking this off. Oof. The steppers are still on. I need to turn that off. Can I turn you off now? All right. Does other stuff work? I don't think it's rotating enough. No, it looks like it's just kind of going back and forth. All right. Okay, I have regrets here. See, I already have the slip ring routed through, and so I can't really move this top piece. I don't know if you can see those wires there. So we're going to have to do something about that. Even after a lot of work, this is still pretty loose, but I think... Oh, this is really hard. I think it should work. I might have to slow down the stepper speed a little bit just to make sure we don't skip it all. We also, not only was the belt wrong, we also need to quickly model a new arrow to point. So we're gonna do that really quick here in 1,000 times speed. I was in the middle of debugging some of the stepper motors when I smelled the magic smoke come out of this guy. So we're going to have to come up with something else to get the 5 volts needed for the Raspberry Pi. I think I have just the idea. We have a benchtop power supply here set to 5 volts. And we just have it hardwired in where the buck converter was. And this is the project now. Okay, so here's the setup. And then I have this guy facing 0 degrees elevation and due north. And if we go ahead and we run the program, it should turn about 180 degrees and point that way. Woo! Look at that go! And see, it's pointing down now. We'll have to get the arrow on there, but this is awesome. We have a pass coming up, and the pass is going to pass almost directly overhead. So this is going to be our one time to get this right. Now, I'm going to turn this on, and it's going to go from south to north. So if this works, this should turn around and be pointing kind of down. And then it should, over the course of the next 10 minutes, pop up and then come down over the horizon. All right, are we ready? Set, go. Okay, and we're off. Overall, I think that was a success. Yeah, the arrow didn't go exactly where I said it would, but the code knew exactly where the satellite was. So what went wrong? Well, I think the translation from the look angles to the stepper motor angles was a little off. And it looks like it was off by a whole lot, but you have to imagine, if you're off by even just a little bit, over the course of 10 minutes, you'll be off by quite a bit. Satellites move pretty quick, and this was the fastest these things were ever going to have to move, and so they got off pretty fast. In the future, I'd like to look back at the code and try and tweak some things, but we'll have to wait for another pass for that. If you want to see more crazy engineering like this, why don't you head on over and subscribe? If you've already done that, why don't you click here and watch the next video?